Before we begin with our next witness, I'd like to make a note to the record. During this morning's testimony by Dr. Kramer of the NTSB, Dr. Kramer provided both oral and written acknowledgement and thanked the Transportation Safety Board of Canada, TSB, for its feedback to the factual report. It is important to note that the feedback that was provided by the TSB on Dr. Kramer's report was strictly on factual elements, as the TSB is an independent Canadian agency and is conducting its own independent investigation of this occurrence. And that collaboration was done under International Maritime Organization protocols, and as Canada has been designated as a substantially interested state to this incident that the MBI is investigating. And that was because the support vessel for the Titan was a Canadian flag vessel, the Polar Prince. We will now hear testimony from Mr. William Kohnen with Hydrospace Group. Mr. Kohnen, the board's recorder, Lieutenant Steele, will now administer your oath.
Good afternoon. Please stand and raise your right hand. A false statement given to an agency of the United States is punishable by fine and/or imprisonment under 18 U.S.C. 1001. Knowing this, do you solemnly swear that the testimony you're about to provide will be the truth, the whole truth, and nothing but the truth, so help you God?
I do.
Thank you. You may be seated.
Good morning, Mr. Kohnen. Thank you for being here today.
Good morning, Mr. Chair.
And just for the record, if you energize your microphone, just please. You should have a green light when you're active.
I have a green light. Good morning, Mr. Chair.
Thank you, sir. Lieutenant Commander Williams will start out with the line of questioning.
Good morning, Mr. Kohnen.
Good morning.
First, thank you for being here with us. As we ask questions, we will take breaks, and if you need a break, please let us know. All of my questions are related to your background, Hydrospace Group, your involvement in the submersible industry, and your interactions with OceanGate. My first round of questions is just related to your general background. Could you please briefly describe your educational background?
Well, that might be difficult to be brief, but yes. I'm a trained engineer. I studied at McGill University in Montreal, did my bachelor's and master's degree in electrical engineering, and with specialty in electromagnetics, wonderful things, and gravitated from space into the hydrospace direction. If it may please the board, if it's the right time, I would like to give some more background information, which I believe might be relevant if this is the proper time to do so, because I believe.
Yes, that's fine.
Commander Williams.
Yes.
There's a lot of interest. First of all, it's a privilege to be here this morning, to be in front of the board. Applaud your work. This is hard stuff to do. It is difficult, it is complicated, but it is very important, and we all understand that we deal with complex stuff and the public has many, many questions. And we are partly here to reassure them that there are men and women that are working day and night, paying attention to things. And I have been in a position of leadership in this industry for quite a few years, and I believe it is important to paint or at least speak to motivations and aspirations on why we do these things. And I'd like to give a little bit of background on how I got to be here. I'm currently the president and CEO of Hydrospace Group in California. I am co-founder of Seamagine Hydrospace, which we established in 1995 for construction of small submersibles. I'm the chair for the Submarine Committee, which used to be called the Manned Undersea Vehicles Committee, for 20 years. I'm the executive director of the World Submarine Organization, an industry association that voices our concerns. I'm co-chair for the American Society of Mechanical Engineering, the Safety Standards Committee for Pressure Vessels for Human Occupancy. We will be referring back to that. It is an investment into the future and the professionalism of engineering. I am been for more than 20 years a member of the Special Review Committee for the American Bureau of Shipping that reviews yearly what the rules are governing manned submersibles. I was a member of the Deep Submersible Pilot Association, which was established in 1968 in Houston and California, and is one of the first instances of members of the industry back then, pilots, grouping together, addressing the need not only for design standards, but also for the manned aspect or the crew aspect for training pilots and so forth. The Deep Submersible Pilot Association, referred to as DSPA, is known worldwide. It disbanded in 2014, and it has been in the endeavor to continue that tradition of training young people and bringing up professionals that we are reinstating it as part of the World Submarine Organization. For all the young people out there who are wondering what they should do with their life, we're here to tell them there is a lot of work to be done out there. The oceans needs people. Knowledge is not a commodity. It is not something you type onto Google. Knowledge is a responsibility. It comes with duties. It comes with care. It must come with reverence. That's why we teach young children to go to school. The only way knowledge works is we write it down, the next person reads it, remembers it, and carries it forward. It is very dangerous to ignore acquired knowledge or dismiss such knowledge. That's how engineering works. The duties we have as leaders, we all know, we're all old enough to understand what the burden is of that responsibility. We need to make sure young people know that as well, and we bring them forward. To that extent, I'd like to just briefly, for the benefit of the board and anybody listening who's wondering, well, where does all this come from, give you some background. I was born in Germany, just like my father and all the many generations before him. I was born on a farm. We grew up on a tradition of independence, hard work, reliance, resourcefulness, and paying attention. My parents moved to Canada in 1965. They had 5 children. I was the second. I'm the second of 8. And they also moved into the unknown. Their aspirations to continue farming, the hundreds of years of farming tradition in Germany, they carried over into the New World. Like my father quoted, he says, "We went from the land of our ancestors to the land of our children." There was a lot of sacrifice it involves. People that listen to this, anybody who's been an immigrant understands what sacrifice means and the resourcefulness it takes. We spent the better half of 25 years finding out that this great land of opportunity has a lot of pitfalls and a lot of people that will take advantage of you. And so did our father. With 8 children, we literally spent 25 years working really hard to save the family farm. Well, like they say, what doesn't kill you makes you stronger. We became pretty darn strong. There was never any money around, but we know how to work. The gifts we got was from our father and our mother. From our mother, we learned discipline, tradition, justice, and competence. From our father, we learned courage, self-reliance, and integrity. And he sent us out into the world and said, okay, I might not see this, but you guys go ahead. You don't get to pay for this. You can only pay it forward. What we've got, essentially what I have, I built with my own hands and with a gift and the talents of God. It takes hard work. And it takes vision and purpose. So I didn't get to be in this position of leadership and taking on all that just out of happenstance. After university, I did have an opportunity to move to California. Wasn't crazy about getting a job. I suppose it's a farmer in me and the sense of independence. Someone says, here's $600, go to California, open a new office. for some engineering services. A lot of interesting stories there, but just like my father was moving into the unknown, it wasn't the first foray for us either. We moved from Germany into Quebec. Didn't speak any language. We learned in school, the kids in school, we only spoke German at home. The kids in school didn't know how to read or write either, so you kind of pick it up. High school, our parents had the good sense to think, you should learn English. It's a good thing in life. Well, in the mid-'70s, the silent revolution of language revolution that was happening in Quebec was pretty tough. 4 years of high school, you were the odd man out. Couldn't really hide that you couldn't speak English, and couldn't really hide that from the French side you were going on the other side. Being the second of 8, we learned, certainly pushed ahead of everybody else and lead into a difficult position. Moving to Canada, I remember when we were told, we didn't know what was going to happen. Going to high school, I was the first one to go to university. Someone forgot to tell me that was supposed to be the best years of my life. I was just scared for 4 years. But that's how you lead. And you have to kind of just charter a course and keep your head down. That's what took me to California. So I had plenty of experience of 25 years of life experience so how do you chart? Well, the 3 years in California, you can be ahead of your time. I brought some very advanced computer simulation technology. You'll hear some of it from Mr. Bart Kemper for stress analysis, which is used everywhere. Well, we had developed at the university the equivalent type for electromagnetic analysis. It's quite advanced. It turns out it was 20 years early. We use a technology today. It was meant for mainframes back then in the late 80s. People thought, oh, you could run it on a PC. Well, what the computers do today in 1 minute used to take 2 days. The industry wasn't ready. But Valiance gets paid off too. So after 3 years of hard work in California, it did bring me in touch with a lot of different people in industry, and I found a place at a space company, Schaefer Magnetics. Mr. Ernie Schaefer, forever in my life will be grateful for him. He was my business grandfather I never had. He taught me how to run business. Schaefer Magnetics was making space systems. It was absolutely fascinating. The company worked on space exploration vehicles like Pioneer, Voyager, Mars Observer. I worked on Hubble, Space Station, Cassini, Iridium. Iridium was groundbreaking. Most satellite systems in the early 90s, if NASA built 3 or 4 satellites, it was a lot. Iridium was planning to build 66 satellites. That was unheard of. Well, those were some real frontiers. It was absolutely fascinating. As a boy that milked cows in Canada, to be in California working for NASA, JPL, the European Space Agency, Japanese Space Agency, that was amazing. Absolutely best job I ever had. It's the only job I've ever had. But serious business. You do realize that every single thing you touch, every single detail you do, people and the mission specialists on these satellite systems, they'll spend 30 years on this thing. And the success of that mission depends on all the hundreds of people that touch every single little bolt in detail, because if that fails, the mission stops. It focuses the mind. Competence is not optional. And I loved the job. Well, to my wife's chagrin, I figured I could do more. So by the time I got my green card, I started the submarine company. It's like, why would you do something like that? Well, that's where it comes down to having a sense of where do you need to go. And God makes funny things in life sometimes. I'd never seen the ocean until I was 25 years old. We literally were milking cows. My friend was getting married in Mexico, ended up in Acapulco, and the first time in my life I put on a snorkel. I'd seen the ocean. That river, it's a dark surface, there's stuff underneath. I put the snorkel on, and I didn't realize how profound the experience was going to be, but I found out that I saw a world I couldn't imagine. In retrospect, it was very humble, but it was amazing. After about an hour of snorkeling, I realized that I'd only had my eyes below the surface, and I was shocked that I thought I'd been diving for an hour, and I realized that this entire world that you have never known, which is so amazing, you could have been on Mars with life on Mars, it would have been the same feeling, was not 10,000 feet away, but it was just an inch below the surface. It stayed with me. By 1993, when I quit my job at Schaefer Magnetics, I had a different vision. And it combined all the work from farming, everything we learned that we lived for, our sense of values, the reason of being of agriculture, that it feeds the world, the level of productivity that we do today, that the world relies on for agriculture, is tremendous. And it is about productivity. That is the point. I remember my father in Germany sharpening his scythe because he was going to go cut grass for 3 cows. He'd spent the whole morning cutting it by hand. This is 1964, not 1864. I drive today through the valleys of California, and I see these large machines. Side note, I love machines. The person sitting at machine in one morning can probably cut 1,000 times of what my father would cut by hand in one morning. Both people working hard. Productivity is not supposed to make your life easy. It is supposed to get more done. The ability in 50 years of my lifetime to see a change in productivity, not of 10 or 20%, not 10 times, but 100 and 1,000-fold, is at the root of how we maintain our society today to feed everybody. It speaks to the agency we have on land and forest management. It is not from robots. It is from the talent and the hard work of people that is leveraged by machines. Machines don't work on their own. And I want young people to know that if you're good at running a machine, you don't have to be a PhD. You apply your talent and you make a machine work to produce 1,000 times more productivity. Now we have agency as humans to take care of things.
Mr. Kohnen, just for the interest of time, could we focus on your background related to submersibles, please?
Well, I understand. I appreciate your patience, but it is getting to that. Because it speaks on why we need submersibles. Because just like how we manage our land resources and our forest resources, we must focus on our ocean resources as well. And it is not through Google that you happen that. People have to go out there, and you can only manage these resources through access. Without tractors, without trucks, without road construction equipment, none of this happens. We have nothing underwater. We do not have access. People float on top and just dump things in there or take things out. Nature cannot just fix that on its own. And the magic of human presence is we have agency, and God gave us a head, it gave us talent, and gave every human 2 hands to do something about it. And we can clean up and we can fix and manage our ocean and coastal resources, but we need machines to do that, not just robots. Why? Because it takes talent. And until someone shows me how they're programming talent into a robot, I'll start paying attention. Start defining what talent is. I don't know how you define talent, but you can sure see it when you see it in action. And young people need to know that. They have talent. Maybe it's not for mathematics, but certainly running machines. We know that well. A farm makes that very clear, who has talent for what. So what's the motivation? The motivation is we must, I think it's President Roosevelt, in his address on the first national forest, which is a natural resource. When we did the first forests 200-300 years ago were considered something dangerous, something dark, something you had to conquer. Well, today we understand it is a very important ecosystem and a natural resource. And he says in an address, When he created the forest rangers, he says, there is nothing more important than a young man and a young woman can do for their country is to become a forest ranger and learn to manage one of the most important natural resources this country has. 100 years ago, that was pretty advanced. That was gutsy for him to go there. That was not the tradition of how people saw forests. Well, today we could do the same thing. Young men and young women need to help manage the resources we have in our coastal waters. And that is why in the next 30, 40, 50 years, we need to have machines go, and we need to have access to the ocean. That's how we have agency. That is a purpose why we're here. That's why this technology is important. It takes innovation. It takes hard work. I might not see it. My wife keeps saying, well, you know, I hope something works out, but can you do something that works out in our lifetime? It's like, well, maybe. So we are shooting out the children into the future. That's why we educate them. That's why we're here. We're telling them, pay attention. It's exciting. It's important. But there's also a cautionary tale. There's things we don't want you to do. There's a lot of hard work to do. So it speaks on the motivation why we're here. Why are we leading? Why are we pushing? Why are we paying attention? Why does it have meaning for us? Because we're shooting, we need to charter a course. We need to be sure, and this is the purpose of this body as well, and the importance of this board hearing. And it's a unique opportunity that hasn't happened in 30 years to have an opportunity like that to address as a group in the nation, as a planet, which direction do we want to take? That's why we're here today. I'm happy to answer questions, but this speaks on aspirations and motivations where we need to do. And this is complicated, it is hard work, and we can only do it all together with collaboration. So we're looking at collaborating with the Coast Guard. We're inviting state agencies from around the world that all have the same issues to see how do we deal with a new mode of transportation like submersibles, which people never thought would exist. But here we are. We're at the juncture of getting it done. So that is the motivation why this is important, why it is important to me, and why it is important for all of us to put our heads together. And I'm happy to answer questions.
Could you please tell me about your experience with submersibles?
Sure. We built our first submersible in 1995 through 96. We had it together in 1997 in California. And we figured what to do with it. The first objective is, why don't we do it, put it in for tourism? We looked at the NVIC, we had interpretations, hired a lawyer, and we actually had the idea of, oh, we can charter it out. So we actually had an admiral lawyer who drafted the whole thing. We had the waivers, and we were going to Catalina Island in U.S. waters, passengers for hire. We said, we can charter it. We mobilized it to Catalina Island, and it didn't take very long, and we got a cease and desist letter from the port of Long Beach that says, please stop, $25,000 penalty per day. Well, that'll get your attention. I suspect Stockton would have paid attention to something like that too. And we ended up in front of the Marine Board in Alameda, California, where they said, okay, what are you thinking? Says, well, that's what the code says. I think we can charter the boat. It's a bareboat charter with a captain. The submersible was classed with the American Bureau of Shipping. And it says, no. Says, do you really think that the people that are going to bareboat charter the submersible know anything about the submersible? And I said, yes, well, no. He says, you're right. I had to agree. And in 1998, the board told me, Mr. Kohnen, as far as the Coast Guard is concerned, no citizen is able to make a risk assessment and a decision of informed consent when it has to do with submersibles. It is just too complicated. I had to agree back then, and I have to agree today. It is an issue that has come up quite a bit on all the waivers and the freedom of people making decisions, and it bespeaks of a very modern challenge we have in society today as the level of technology keeps increasing to the point where it is no longer possible for a citizen of the country to understand all the implications of the technology that is around them. Informed consent is a big issue. It's not going away. It's going to get more difficult. And very specifically with submersibles, no. I've heard many testimonies, many questions coming along, asking people what they thought and different opinions, which I thought was misdirected because no individual is able to make a risk assessment to find out if this thing is safe or not. Just not possible. So back to 1998, they said, okay, well, go home, you have class, but you need to have a full certificate of inspection by the U.S. Coast Guard. You need to submit all the papers and have to give credit where credit is due. In retrospect, we submitted through the OCMI, we submitted all our documents. It went to the Marine Safety Center. They processed it. To us, it seemed like a very long time. They processed it in 4 months. By the end of September, we had everything. Well, we thought it was a very long time. After 20 years, there was some very good participation. So I have to, after the fact, give them credit for being active. Well, it was end of September by the time we got the COI, and the season was over. So it cost us the whole season. Cost us a bunch of money. But that wasn't the hardest part. The hardest part is the Coast Guard also said, well, Mr. Kohnen, to pilot these things, your pilots must have a certified captain's license by the U.S. Coast Guard. So, okay, what does that look like? It's like, well, we have a 150-ton license. It's like, well, how's that going to help them pilot a submersible? It's like, well, it's not, but we don't have anything else. So in terms of experience and breaking new frontiers, we had to develop a pilot training program. It is still one of the proudest assets we have at the company today, because we spent a year working with the LA Long Beach Coast Guard Department to create a small submersible U.S. Coast Guard approved pilot license training program. It took a while. We trained probably a dozen pilots that had either an endorsement to their captain's license as a small submersible pilot, or more than half of them, it was their original captain's license. It was quite extensive. We took the crew. We had a requirement of training them for 40 hours in classwork. They had to have 20 hours practical experience. They had to pass a written test. They had to apply to the U.S. Coast Guard. Coast Guard had their standard requirements, seamanship of 90 days. They had to have a physical. They had to have drug testing. And it required that they have EMT training. When they applied to the Coast Guard and they passed for entry, the Coast Guard would administer an exam on our submersible. It's an exam that we gave the Coast Guard a number of questions to, and they had to administer to the pilots. But the pilots also had to show up at the Coast Guard with a certificate from the company that said that they'd passed the written exam and the training program. And if they passed all that, they actually got a Coast Guard certified pilot license. That was a big achievement, and nobody has ever done that in the past 30 years. Atlantis Submarines has some large tourist submarines in the Virgin Islands and in Hawaii, Guam, but no one's ever operated a small submersible with passengers for hire under an OCMI license. We did. We ran it all the way through 2002. So we're speaking from direct experience, knowing that it is possible, it is feasible, and it's doable. Question is it scalable? We can speak onto that later. There's a lot to be said in terms of where do we need to go. But that is the experience we had, the ability to put that together, and I must give credit again to the LA Long Beach Port Coast Guard, that the level of collaboration we had to develop this pilot training program was just stellar. There's a lot of complaints on all sorts of things by the Coast Guard. I mean, there's always things, but on that application, again, in retrospect, it really was something special. Now, it turns out that part of the challenges we have is there's a lot of independence on the Coast Guard captains from port to port. and the adjudication on what they recognize has a lot of variance. It is a problem. The independence that each Coast Guard captain has is jealously guarded because they know by the time if you're in DC, whoever's in DC, eventually end up at a port, and you like to have that independence of judgment. Makes a country work, but it has its challenges. By 1999, we started operation. We've towed thousands and thousands of people safely, women, children. It was a two-person submersible. We're the first ones to come up with these little bubble submersibles. We built some more. The next one went into the Cayman Islands. Cayman Islands has its own Cayman Island Shipping Registry. That's the equivalent of their Coast Guard. They have a lot of traditions on submersibles. To put that in for tourism, they said, okay, we do, bring it over, but we want all your pilots to be U.S. Coast Guard certified pilots. It's like, that's not a problem. We moved some of our U.S. Coast Guard pilots to Cayman Islands. After a year, we pleaded and says, okay, do we have permission now that you know how this system works? Can we train native? Can we train in Cayman and certify pilots in Cayman under the same program? They agreed. Why? Because the foundations and the integrity of the program were solid, and it was underwritten by the U.S. Coast Guard. So we didn't just make this stuff up. It's brand new. Is it innovation? Yeah. Is it flashy? No. But it's really, really important, and it's fundamental on how we do. This program, this training program, is something we've been carrying for 25 years, being very careful, and we export that process. It gets us into the countries around the world where the governments are not sure what they should be applying. It's like, well, try this. Here's a template. We have built 16 submersibles today, over 25 years. We consider them the best submersibles in the world. We pay attention. We just delivered the last submersible to the National Geographic Society, who after years and years of figuring out what they should buy, chose Seamage and Hydrospace to buy their submersible. They'd never bought an asset in the life of the society. The first asset they have on the books is one of our submersibles. We're proud of that. And not only because the vehicle is good, is because we pay attention, not just to detail, but how we manage and how we train the people.
Mr. Kohnen, those submersibles, are they classified?
Yes, ma'am. They're all
classified?
classed by the American Bureau of Shipping. The experience led us from the very beginning, working with the Coast Guard to work these details out in the face where the Coast Guard says we don't have anything. We worked with them. We worked with the American Bureau of Shipping very closely to do that. It was innovative. And you want to talk about innovation? And I want to make it very clear that safety and innovation are not mutually exclusive aims. You can do innovation. You just have to do it right. The competence is not optional. You have to pay attention. What did we do? The first submersible we said, Mr. Kohnen, you're crazy, because our two-person submersible had the pilot on the outside. You might still see some of these on there. So we had two people inside the bubble, and the pilot was outside. Who makes a submersible with a pilot outside? Well, it was a very nice, little, comfortable, it's like a limo tour. You have a lot of privacy in your own little cabin. Moms and their kids would just live it. That was unheard of. Not only did we get it ABS classed, we got it through Coast Guard certification, and we got it under pilot training program. So nobody can tell me that it's hard to get innovation through. We are making very deep submersibles today. They're all classed. We work with ABS, very closely with ABS. I've been on the Special Industry Committee. ABS invites industry to help them write their rules and review their rules. They have a special committee on submersibles codes. It's voluntary. You don't get paid for this. You just invest your time and energy into it. So I've been with ABS on their special committee for more than 20 years. It's collaborative effort. This also brought me to the next phase of taking over the chairmanship of the Marine Technology Society Committee on Manned Submersibles. That was in 2003. Most people thought, you know, submersibles, this is all going to be taken over by robotic systems. There was not much attention being paid at all on it. It's had very humble beginnings, but I pushed, coming from space, where it was a professional industry, where there was engineers, thousands of engineers working around the world with conferences discussing technologies, regulations, and all that within that industry. That was my aspiration to come into the hydrospace industry, and finding out it was a whole lot more parochial. Well, that's where my mother spoke to me and saying, there needs to be better traditions than that. And I set up the first conference where we'd invite all professionals from around the world to meet one place for 3 days, and everyone sit around the table to discuss manufacturers, operators, regulators, owners, enthusiasts to sit at the table and work out issues and talk about the latest technologies, the latest expeditions, the latest operations. What are the foreseeable regulations that are coming in? And invite the regulators to listen in what the industry was done. Well, in 2003, I can tell you it was very humble. It was part of the underwater intervention, and I've been leading that for the last 21 years, bringing the world together within that conference to discuss very serious industry issues. And I invited the American Bureau of Shipping. I heard Roy's testimony, Mr. Thomas's testimony on Monday. Did a great job. They try hard. And it does make progress. And I've asked Mr. Thomas, can you come, and he came into the very first one in 2003, can you come and give an idea to the audience what ABS is planning for their next rule changes, or what are they looking for, so that it's done in community and reviewed. And if people have issues and questions, they can be done there and then. Well, credit to Mr. Thomas, he's been doing this for 21 years. And every single year he comes to brief everybody in industry, and we can ask questions, just like we do here today in an open dialogue. That is called progress. Is it slow? Yeah, it's slow, but it works. That is our connection to the American Bureau of Shipping and the connection to the classification societies, working with the Lloyd's Registry people and with DNV, and at the time, Germanische Lloyd's. Our connection to Germanische Lloyd's as chair of the industry and inviting many people, they play a big important part here in the discussion of the Titan. We can jump ahead a little bit, but one of the key things that happened, and there are many questions on the technicalities of a submersible, but the much bigger overarching issue with Titan was that did OceanGate have any choice to class their submersible? That was one of my big concerns. Because if everybody bows out and no bids, then Titan would have, OceanGate would have an option, say, well, you know, we asked and nobody was ready for it. Well, Mr. Thomas did say, ABS said, hey, we have to no bid. We do not have any knowledge on the technology for carbon fibers, which is fair enough. Lloyd's Registry, the discussion yesterday, I believe Lloyd's Registry did attend the dives in the Bahamas. They were right there. They witnessed the dives. And after the dives, decided they were not going to bid on it. So it only left the DNV group.
Mr. Kohnen, do you know that knowledge firsthand about
No, I do
Lloyd's
not.
Registry? Okay, I just want to make for the record.
So
that
we could
You're
take-
speculating on that.
I'm speculating on that. But it's part of the reports. I do an annual report on the industry overview. I mean, that is part of the something I do. One of the very first things I did coming into the submarine industry, one of the first persons I contacted was Captain Don Walsh, 1994. He was in Long Beach, and I talked to Dr. Walsh. And the first thing I did is I asked him for a report to give me an idea of who is doing what. The report on the state of the industry back then, 1994, 1995. It actually cost a lot of money, but it was worth it. These reports today, I make every single year for free. Why? Because it's important for people to know. And that is part of we do within the conference and within MTS. It comes down to the question of how is that tied to the class agencies? Well, because it is important to bring in the class agencies and find out what is going on. Mr. Harold Powley is probably someone that would be helpful to talk to. Mr. Harold Powley was a department chair of DNVGL at the time. Mr. Powley was also the European representative at the ASME Pressure Safety Standards Committee for the pressure vessels for human occupancy. We had a close relationship, for sure, with Mr. Powley, and we had many, many discussions. One of the services that DNVGL provides today and provided back then was very custom, highly specialized engineering within their classification department. They have very experienced engineers that was focusing on submarine technology. And I remember talking with Mr. Powley, and he said he bent over backwards and spent 2 or 3 months creating a proposal for OceanGate to certify the Titan. He says it was really difficult, but they really tried to find a way to do it. And they made a proposal, and they made a bid. And you work.
Sir, can you just clarify the time frame that occurred?
This would be 2018, 2019.
Thank you.
Yes, it was early in. They were looking. It was at the time when were doing the Bahamas as well. It was an issue. Can you actually class something like that? I'm sure Mr. Powley would be more than happy to share some of that. He is retired now, he's in Germany, but to contribute, because he spent a lot of hours and a lot of energy that he got flack for because they weren't being paid for it to come up with a proposal. But it was important. And like much of the other stuff, it was rejected out of hand.
Objection, just to clarify again, the basis for the information is Mr. Kohnen's discussion with Mr. Powell.
Mr. Harold Powley, department chair of DNVGL in Hamburg.
Understood.
And he communicated that information directly to you, sir?
Yes. Because there is a sense of part of the leadership and the discussion we have is to find out what is happening, what do you do? And it's like, okay, this is really important. And Mr. Powley understood that, and the GL group out of Hamburg had the capability to do that. Now, it wasn't particularly cheap, but that wasn't the point. It would take time and it would cost money. But somebody stood up and says, yes, we can do this, we can work with it.
Did you actually get a chance to review that report, sir?
No, I was not privy, no. But I'm sure Mr. Powley would be happy to provide that information, and it's really important. But it is also to say that within this industry, when the public is asking, okay, is anybody paying attention here? Yeah, we were paying attention. We have hundreds of thousands of engineers silently working day and night doing these things. Nobody knows. We don't need to have adulation for it. We just do this because we are professionals. And that was exactly one of those works. And I don't think Mr. Powley really minded doing all that work, but it was highly disappointing on the casual rejection nature that it was received at, because it was an important step for them to step up and provide that proposal. So in terms of industry experience, submersible experience, going all the way through working with, not just working with the class agencies, but engaging them in the dialogue with industry and making sure industry has a dialogue with the class agencies. And it's not about complaining, it's do something about it. And that is part of the deal to work on the conference. Say, okay, you have grievances, let's talk about it. But you have the responsibility to show up at the conference and talk. So yeah, I have a big Rolodex, and it's not just names, but I know what the people are doing Why? Because I engage them and I say, you have to come, you have to say something about this, you have to present about it. Stand and be counted, you're part of the community.
Mr. Kohnen, can we start talking about Hydrospace Group and your involvement with acrylic windows?
Yes, ma'am. The let's go back. We have been making acrylic windows in the conversation we're talking to are very specifically acrylic windows for pressure vessels for human occupancy. So just for definition, we will call these PVHO, pressure vessel for human occupancy. It is a very important field. I believe Mr. Stanley spoke about it. Other people might have spoke about it. It is a very unique code on this planet today, without big over-exaggeration. The PVHO code comes from a very distinct work for Dr. Jerry Statue, working for the U.S. Navy, spending 40 years testing a new material. At the time, acrylic was pretty special in the 60s and 70s, to find out how can we render this technology safe to make windows out of them. Acrylic was invented in Germany in the 1930s, and I believe the Trieste submarine that made the historic dive in 1960 was one of the first ones. That was one of the discoveries or the adulations of Auguste Piccard, is to use acrylic in the window because it is not brittle like glass. Mr. Statue spent 40 years. The testing, physical testing for 40 years of finding out how do these windows behave, different geometries, round windows, flat windows, circular windows, cylindrical windows, how do they behave under pressure, to come up with a design methodology to find out how can you determine that these materials and these configurations are safe. This led in 1977 to the publication of the first ASME PVHO safety standard. I have looked. There is no other country that has a basis of data of testing to come up with an alternative, which is why today's ASME PVHO code is a de facto international standard document. It is central to all the discussions we have over here. ASME PVHO is part of the CFRs in this country. It is the law. It is often not mentioned. It is central to this. And what does constitute a PVHO? A PVHO is any pressure vessel with a pressure differential of greater than 2 psi. If you put human occupancy in it, it applies. We have other great national issues with that, especially where medical devices are involved and where we have an epidemic of illegal chambers in this country being propagated. It's a great concern to the PVHO community, and people forget that they think PVHO only applies after 15 psi pressure, and it's 2 psi. It's a big problem, not related to this cause, but it is a big national issue. ASME PVHO is a very powerful, very important part for the future and the innovation we need. Because pressure vessels, you do not do anything underwater if it doesn't involve pressure vessels. Humans are not adapted for that environment. So it's connected to Hydrospace. We are specialists in pressure vessels for human occupancy. We work on space systems, space simulators, altitude chambers, medical systems, hyperbaric chambers, diving systems, Navy systems, submarines, habitats. It's an exciting field. It's very broad. And it's all related to PVHO, pressure vessels for human occupancy. And people don't go into steel containers. Acrylic is central to these things. Like most submersibles today have a very high degree of acrylics. So yes, we are specialists. The first windows we made at Seamagine was in 1996. They were all under ABS survey. We've been making, to date, Hydrospace has made over 3,000 windows. And to be clear, it's highly regulated. And every single window has a unique trace number for which we must retain all the quality assurance data for 20 years in our offices for traceability. And any single point someone come in and say, window number 1,544, show me where it came from, and we can show them the entire traceability of material production history. That's what PVHO does. It is a lot of requirements. You have to pay attention and say, oh, but there's a lot of liability. Yeah, there is, but life has a lot of liability. You just have to do it right. One would say, like our mother said, don't lie, cheat, or steal. You'll be okay. It is part of PVHO. It is unique in the world. Mr. Jerry Statue put it in. The committee meets 3 times each year. It is industry-based. People volunteer, engineers in the country volunteer. And I've been a soldier with PVHO for 20 years. I've been in a leadership position for 10 years. It's important stuff. In fact, when Dr. Statue passed, I'd heard that his information and all his paperwork was going to be boxed away and maybe not found again. And I asked the family to just put it in a truck and ship it to California. And I got a letter from them assigning all of his research and all of his books and works to Hydrospace, promising the family that we'd carry on the innovation and the important work that he had started back in the 1960s. It's not for adulations, it's because it is important. Someone has to understand how important it is. And that is where it ties for Windows. Everybody needs a window. It is complicated. We get lots of questions. We spend a lot of time on the phone letting people know what the code really says, what they must do, what their responsibilities are. And there are a lot of responsibilities for the user on how to use it, how to maintain it, how to install it in their system, what their responsibilities are. They're serious.
With respect to the acrylic window, can you explain your interactions with OceanGate with regards to their acrylic window?
Yes, I can. OceanGate had an interesting idea. There's a lot of talk about what are the shapes of the windows. And they're flat windows and round windows. The Romans figured out that. Goes back to the time of the Romans. Say, how so? Well, because people figured out if you needed a doorway, you could have 2 posts with a flat beam across, made a good doorway. The Romans figured out, hey, you know what? If you make an arch, it's a lot stronger. The invention of the arch was a huge human discovery. Seems trivial, but it isn't. It allowed the Romans to build the Colosseum that still stands today. The cathedrals, all the arch. The power of the arch is what makes acrylic windows really strong for holding underwater pressure. You can make flat windows, but they're not going to be very large. To put that in context, the Alvin window. The Alvin is a deep submersible for the United States. It's rated to 6,500 meters. Most of all these deep 6,000 and deeper submersibles for research all use flat windows. They're very thick. They're in the neighborhood of 5, 6, 7 inches thick. But they only have a diameter of 7 or 5, 6, 7 inches. It's not a big diameter. Works fine. If you want larger diameters, you're best off to going to an arch. They call these spherical sector windows. The outside is round and the inside is round. 100% certifiable, all tests, we have all the PVHO rules that says how you design these. The issue is when you have a spherical window, you do not get a deformation, but you get some demagnification effect. When you look through it, things look a little bit farther away. So, well, that doesn't really make any sort of difference. But if you're trying to sell a thrill ride, you want to say, well, I want things to look closer. Okay? Flat windows do not have this visual effect. And OceanGate thought, well, maybe we could have a hybrid window of it is round and it is flat, flat on the inside and round on the outside, and it'd be as strong as an arch, and we have the optical benefits of a flat window. Well, it's worth looking into it. It's an idea. We don't know. It's a non-standard window. You'd have to do testing for it, but it's worth trying out. If it's important for your business, figure it out. You want some better optical effects and the strength. And that was a communication we had with OceanGate. So sure, they designed the window. We did, and said, look, you need to do a bunch of testing. It is a non-standard window. This is PVHO. We cannot certify to PVHO because it's non-standard. It can only be rendered safe once you do the testing on it. Now, there's a lot of question today on, well, what if it's something that doesn't exist? I mean, there's no testing standard. And I'd like to put that on the record today for the Marine Board, is that we do have these test procedures. They are enshrined in law.
Sir, I think I could actually bring that up. Lieutenant Steele, could you bring up Coast Guard Exhibit 105? Scroll down to page 7.
Well, that was a good picture, the very first one they had. Just a cross-section? Can you go where you see the window, the cross-section of the window? I think it was your first page. Yeah, right there. That one right there. No. One more. Right there.
Is this what you were describing earlier?
Yes. So you can see on this picture over here what is the traditionally approved acrylic window, which is spherical sector. You see the two arches on the outside, on the inside, and you have that little extra piece of acrylic that fills in the center. And that little extra fill into the center gives you an optical effect. It's like, well, is it as strong as an arch? Is it as strong as a flat window? What does it do? It's like, well, you have to find out. You either use computer analysis to find out, or testing it, or a combination of the two. But it is considered a non-standard geometry. Right?
Lieutenant Steele, could you move to page 7? Could you scroll in just a little bit close to the bottom of the page? Mr. Kohnen, are you familiar with this email between OceanGate and Hydrospace?
Yes.
Were you the author of this email?
Yes.
What you were just previously describing, the guidelines, it's at the ASME PVHO 1, that last paragraph right there. They provide guidelines to establish the safe operational depth of an acrylic window that is of non-standard geometry.
Yes.
And then
yes.
if we scroll down to page 8,
The top of 8.
the top of 8,
Right there, section 2. So, not only did we tell them what they had to do with that window, we also gave them book, chapter, and verse of how they had to test it. In section 2-2, tag 6, non-standard window geometries and standard window geometries with lower conversion factors is a set of test procedures required to qualify a window. Why do we have this? Is because Dr. Statue used these procedures for 40 years to establish empirically the safety of the acrylic windows. And here I would like to extrapolate and said it wasn't just acrylic windows, but it is applied to pressure PVHO components that are using nonlinear materials, non-metallic nonlinear materials, which acrylic is. It is a lengthy process, and just to be sure what constitutes a proper test regime, there are a lot of opinions. It's not a matter of opinion. It is in the book. And again, it is law in the United States.
Could you briefly describe some of those testing requirements for a non-standard window?
Yes. The basis of evaluating a component like that has three parts to it because material behaves in different ways. And this is for the benefit of the board, but also the public that is listening that are wondering, well, I mean, what is a test program? It is not just doing a dive or two dives. The first phase is verifying that you understand how the material does, what is the failure level of the material. And it is the proof testing of the material. The test requires that you have at least 5 samples that you test to destruction, and the pressure, the measured pressure of failure must be statistically significant within the same zone. Otherwise, it means you don't know. It's not related, and it's not linear. So all 5 have to fail roughly in the same zone. It does allow, which is important, scale model testing. It is enshrined in the code, but you have to do at least one full size, enabled to verify that your scale models are working. So that's 5 of them to destruction. The other test is cyclic fatigue. Everybody, I am sure everybody on the behavior of materials, everybody in their life at some point, certainly on the farm, has taken a piece of wire and bent it long enough until you break the wire. Okay, well, that's called cyclic fatigue. And everybody can understand that if you just bend it a little bit, it'll never break. But if you bend it a lot, eventually it does. The design makes sure that the displacement and how much material moves is very small and significant so that the cyclic fatigue does not affect it. To qualify a window, you have to put it to maximum working pressure for 1,000 cycles. That takes a while. There's a minimum time you have to do. That is generally takes 9 months. And at the end of the 9 months, you must see no evidence of any cracking or defect in the window. And the third part is plastic materials creep. All materials creep, which means when you're under pressure, it deforms. It kind of makes sense. If you have a piece of plastic, if it's warm and it's sitting under load somewhere, you can see that it bends. The creep test is really important, and part of it is if it's under pressure, does it keep moving? Metal doesn't do that. Acrylic does. And it requires, the code required, that you do that at full pressure for 80,000 hours. That was in the book. 80,000 hours is 9.5 years. Why am I bringing it up? Because as part of my duties on the ASME PVHO committee, I was part of the group that worked to change that element and say, this is not realistic. We are not getting new geometries approved because you cannot afford 9.5 years to perform this test. That is also innovation. We have methods. And there is now in the book, it was revised in 2016, 17, 18. I can check. It is now part of the book. It was a code case. I can talk more about the code cases. But it was to change that 80,000 hours as an alternative test method, which says you can use multiple windows and expose it to 300 hours, which is a lot shorter, but at elevated pressure. It's described in the book. That all of a sudden made this possible to perform one of these tests. It would cost you more money, but at least it was reasonable. That is also innovation. That Hydrospace was actively in to make sure that we have more possibilities for industry to be able to try new things. We're allowed to try new things, but you have to do it right. And yes, that email that we just saw, we gave very clear directions. There's many questions. That might be your next question. What was the rating on the window? And like, what was the final rating? The conversations with OceanGate says, look, you don't know what the rating is. Until you test it, you cannot give it a rating, but it does not have a 4,000 meter rating. You cannot say that. The best rating you can give it, which is totally valid, is as a flat window. That hump on the outside wouldn't hurt anything to add to the rating, but it is just a flat window. And the window they had right there was a completely valid flat, which is called a conical frustum window. But the effective thickness would be less. Calculated per ASME PVHO standard, that rating at 50 degrees F was 945 PSI. That is what was marked on the window. That's how we registered it. That's how it's in our database. And it was,
And to confirm, when operating at 4,000 meters of depth, what would the pressures be down there?
oh, the rating for that is 5,800 PSI. So it gets mixed up on how PSI translates to depth. But 945 PSI translates to 650 meters, 2,150 feet. And the direction was to Ocean Gate, yeah, you can do, this window needs to be tested. Go ahead, test it. But you should buy a proper window also. We gave him the drawing and said, in fact, we even had extra material to make the second one because we're pretty sure that was just going to come. For the time and the cost of money, just get it done and you have a full replacement window that's fully certified, rated for 4,000 meters.
So to confirm, Lieutenant Steele, could you bring back up Exhibit 1, Coast Guard Exhibit 105, and go to page 8? What you're speaking about, Mr. Kohnen, are you talking about that second paragraph saying that you would consider in parallel task of fabricating a spherical sector dome?
Yes.
And can you just explain what the purpose of that would have been?
Well, it is to do the testing and operation with a submersible while they're actually testing the hybrid window, which was meant to go into a test jig for doing pressure testing, not to be run in a submersible. And I did expect them to buy it. I actually bought the spare material, which we still have in the shop. And the idea is, look, it retrofits exactly in the same seat. It is completely replaceable. Within 24 hours, you can put that window in there and you can dive in full safety. I believe it was $25,000 and it would take 12 weeks to make. Says we're still all rigged up for it. Do it right now. We'll have it in no time. We gave them the drawing, knowing full well, giving them the drawing, they could go other places to buy it as well. It's like, it wasn't about the money. It's just do it right. And we figured they could buy it in any number of places, and in the end they did. They just didn't buy it from us.
Did Ocean Gate ever explain to you why they didn't purchase it from you?
No, but I had my ideas.
Did you have any conversations with Ocean Gate about pursuing the testing besides the email correspondence?
No, we had, it's in part related. We did not. I did expect to hear from them at the PVHO committee because this is where they would have reported some of the test data.
Objection, can we just specify when we say Ocean Gate, if Mr. Kohnen is referring to particular individuals by title or name that he was communicating with?
Yes, was it generally the CEO, Mr. Rush, or other individuals at Ocean
Both.
Gate?
To define, it would be either Mr. Tony Nissen and Stockton. Look,
Thank you.
we talked a lot. There was an open line of communication. Back again, this didn't happen this happened over a period of 14 years. As chair of the industry, we invited Ocean Gate, showed up sometime in 2007, 2008. That's when we first had contact with Ocean Gate. They were looking for a submersible. We had a submersible available secondhand that they were interested in. And Mr. Sohnlein and Stockton, they were interested, but they found the Antipodes that Mr. Hoffman was selling was cheaper. It's like, okay, But by the time they showed up at the conference, it is an open door policy. It is, everybody is welcome to put it in. And so we had lots of conversation with Stockton.
Did OceanGate ever communicate the reasons for not pursuing either testing geometry with you?
Something happened at OceanGate, and I believe APL got the same feeling, because for many times before, there was a lot of conversation of all the testing they were going to do. And they changed their mind. Somewhere they changed their mind. And I don't know when it happened, but there was a change. And it is somewhere around the time where we delivered the window. It's like, what do you mean you're not, you need to be doing the testing. And it was left as a hanging chad, we'll see. It's like, no, this is not optional. And we discussed, and that's why we made it very, very explicitly clear to Mr. Tony Nissen and to Stockton that the rating of that window was 945 PSI, and you have a duty to test it, and this is how you have to test it. And if you want to do anything else, buy the spherical window, because that is, it is fully rated, fully tested, we understand it.
Lieutenant Steele, could you bring up that same exhibit again, Exhibit 105? And can we move down to page 25, please? Mr. Kohnen, this is a communication between you and OceanGate, where you sent OceanGate a preliminary study of behavior completed by Kemper Engineering of a spherical sector window with a flat inside, low-pressure surface. Did OceanGate request this type of analysis?
No.
Why did you reach out to Kemper Engineering regarding this window?
Because this is part of the innovation, is part of the knowledge we have, and is to communicate to, it is open source information, it is to communicate to OceanGate, look, there is testing involved, but there are also other resources available. And Mr. Kemper will talk more about it this afternoon. Designed by analysis, and the analysis we have, the capabilities we have today, the analytical capabilities we have today far surpass those we had in the 60s and 70s, which is where the testing program comes from. And I said, and I asked Bart, look, we need to let OceanGate understand what this looks like, what the behavior of this is, that it is possible, that it is feasible. It was all members in the industry were happy to help and support OceanGate. They got a tremendous amount of free engineering. They're asking lots of questions. Everybody's more willing to contribute. I considered this an action of goodwill from Kemper to give some idea what was possible, and it led to more analysis. But it is to support OceanGate and their engineering department to say, look, these are the type of analysis that can help you.
Lieutenant Steele, could we move to page 13, please? Mr. Kohnen, is this the report that was included as part of that email?
Yes.
And this was provided to OceanGate?
Yes.
I'd like to bring your attention to conclusion number 2 that states the specified Cyclops design, which we now know was Titan, at 5,800 PSI indicates significant strain that is consistent with potential short cycle failure modes. As this was provided to OceanGate, did you ever receive any communication back from OceanGate regarding this analysis?
No, the communication is please take that up with a professional engineer like Kemper Engineering to pursue that further, and they did more analysis to understand it better. But it did indicate that, look, this is not doing what you think it's doing.
And are you aware if OceanGate ever reached out to Mr. Kemper regarding this analysis?
I believe so. You can ask Mr. Kemper this afternoon, but we are aware of the idea. It's a good idea, but there is a process of doing it to evaluate it. And we just wanted to make sure OceanGate was aware that there was expertise in the country to perform these analyses and to support them.
Lieutenant Steele, could you now bring up Exhibit 080, the quote from Hydrospace Group to OceanGate? And page 1, please. If we could scroll down to the notes section. So the note number 1 states the job will be started with submittal of purchase order, engineering drawing, and PVHO Form VP2. Can you explain to me what PVHO Form VP2 is?
Yes. So every PVHO window comes with, I call 5 birth certificates. There's 5 forms that create the full certification, validation of a window. And they're called for viewport forms. So VP1 is the fabrication certificate. VP2 is the design certificate. And this is where you have to report all the design parameters that went into the calculations for the rating of the window. That must be performed by a professional engineer, and this is generally always provided to Hydrospace for the fabrication of the window. We cannot provide a fabrication certificate if we do not have a signed design certificate for it.
And did you ever receive a PVHO Form VP2 from OceanGate?
No.
So did Hydrospace actually construct a window for OceanGate?
We built the non-standard window. This quote was for the certified window. So this is a quote for the spherical sector round window.
I actually think we might have the quote for the non-standard one. If it was, we might have to go down a few pages.
Let's see, go up.
Well, we can pull up that exhibit later, but
But either case, yeah, no, we did not get, they could not do a Form VP2 for the experimental window, which is why they had to test it. And in fact, the Form VP2 has a form on it where the qualification, it'd be interesting. The Form VP2 has a section in it where you can fill it in that says on what test validation data you are qualifying the window. If you do not have the calculation details and the formulas you used, it has a qualification by testing section, which is usually ignored by most people, but that is what they would have had to fill in to qualify the non-standard window. But it takes time.
And did Hydrospace end up making the non-standard acrylic window requested by OceanGate?
Yes,
And how many did you make for them?
one.
Just one? And just to confirm, you did not give the PVHO
No.
certification?
No. You have we gave them an inspection report that is on there that defines the dimensional and material specifications. In those cases, we do that many times for the U.S. government where they have non-standard windows, but they're exempt from PVHO, where we give them a commercial certification of fabrication, but we use same PVHO processes and PVHO certified material. 2 of the certifications that go with a window have to do with the testing. Each PVHO window must come from a casting, and each casting must have a sample sent to the lab and tested to verify that the material meets the minimum requirements of PVHO. So it's quite extensive. So it used PVHO certified material, but it was on a non-standard design.
Thank you. That concludes my questions.
Thank you. Tom? Okay. Commander Whalen has a question.
Good afternoon, Mr. Kohnen. I have a few follow-up questions. You had mentioned the 1,000 cycles for a acrylic window to be tested to. Is that to the rated depth?
Yes, it is.
And is that for a certain period of time or just 1,000 cycles to depth and then?
There is a profile where there is a maximum rate of pressurization, so the ramp-up time, the hold time, and the ramp-down time is predefined. It takes a while.
And you had stated that you had only, I'm going to use the term built, but created one window for Ocean Gate.
Yes.
Were you aware that there was another window created based upon the window that you created being damaged in 2019?
I did learn, and I figured they had to buy a proper window somewhere, and I suspected from, well, Stockton wasn't very happy with me at some point, and they had the opportunity to go buy them anywhere, and I understood.
Okay.
They went somewhere else.
Recorder, can you please bring back up Exhibit 105? Page 1. And in the bottom right, it has a drawing number. Do you see that, Mr. Kohnen?
Yes.
It's 15 TAC 040 TAC MEC TAC 000461 Rev B.
Yes.
And what does that mean to you as a builder of this acrylic window?
That's a number that's assigned by the manufacturer to identify the window.
So it's to this drawing, correct?
To this drawing, correct.
So you would build it to the specifications of this drawing.
Yes.
And as you built it to the specifications of this drawing, it was rated to the PSI of 945 PSI.
That's what we assigned, and for the avoidance of doubt with the director of engineering of what they thought this might be rated to, is what the PVHO rating would be for that window.
Lieutenant Steele, can you please bring up Exhibit 106?
Can we take a quick break for 106 to come up?
Yeah, but I want to get it before lunch.
We're going to take a quick recess to get the exhibit ready. We're close to lunch, so we'll take a short break and come back at 12:30, and then we'll do another quick session and break for lunch, sir. Does that work for you, Mr. Kohnen?
Yes, it does.
Okay.